This is tutorial for boundary layer number 7. The question is simple. We need to determine the value of CD, drag coefficient for velocity profile for y over delta by the power of 1 over 9. So you have two choices, whether you want to use the idea of y over delta here, or you also could change it into the function of eta. If you change it, so please use the proper equation for function of eta. So let's say we have a velocity profile of turbulent boundary layer. So written as u over u y over delta by the power of 1 over 9, or equal to eta 1 over 9 here. So and then we have shear stress from the von Karman equation or momentum integral equation, rho u squared d theta dx. And please bear in mind that we are solving turbulent boundary layer, means that we cannot use the shear stress from Newton's viscosity law. So we use Blasius resistance equation. So it's commonly it can be written for 1 over 9 as 0.0225 rho u square nu over u delta by the power of 1 over 4. In some textbook, they will write as mu over rho u delta. So from our previous lesson, we could calculate the value of theta is 9 over 110 delta. We substitute in von Karman equation. So finally, we could write as this one. And then what we need to do is we equalize with the Blasius solution of shear stress. So we have 0.0818 rho u squared d delta dx equals 0.0225 rho u squared nu over u delta by the power of 1 over 4. And then we need to bring all the value of delta to the right side with the d delta here, and then we bring everything including the dx here to the left hand side. We need to solve this equation, so we integral both sides, left and right, and for integral result we get c a constant, so we put the condition of if the free stream velocity is equal to 0, the boundary layer thickness is not occur yet, so it's equal to 0. So the c is equal to 0, means that the value here is 0, and then we could simplify the value of delta here as this one. And then from this one we could calculate again. You may see the solution of this one in our notes in previous lesson. So from the delta here, so we could calculate the drag force, and then from the drag force we could calculate the value of CD. You may also calculate the value of CD by the idea of 2 theta over L, and you could do that. And finally, you will get the CD here, the drag coefficient is equal to 0.0698 over Reynolds by the power of 1 over 6.